Hi everyone. Today I'm going to do a quick explanation of combinations, which is just a fancy word for how we can count different things. So let's make a little story here. Let's say there are three friends, Alice, Bob and Charlie. Now these three friends, they decide we have to select a subset of this group. So let's say we want a set of, now this is going to sound odd, a set of 0 people. How many ways could I select 0 people from this group? Well, the only way I could select 0 people is if I had the empty set. So there is exactly one way in which I could select 0 people. Now what if I wanted to select just one person? I need one volunteer from the group to do a very important job. Well, I could select Alice, so there I just use A for Alice. So there's a set of a single person. Or of course I could select Bob, or perhaps I could select Charlie. Now there's no other possibilities. There are 3 ways in which I could select one person from the original group of 3 people. So there's my original set of people. What if, you could probably see where I'm going here, I'm working systematically. What if I wanted to have a set of 2 people? I need dance partners for a dancing competition. Well, I could select Alice and Bob. What else could I do? I could select Alice and then Charlie. Not the only ones yet, but that's Alice with the paired with each of the other 2. What if I start now with Bob? Now Bob could be paired with Alice, but wait a minute, that one's the same as the first one, so that one really isn't a new combination of dance partners. If I said Alice and Bob come forward to dance, or if I said Bob and Alice, it's really the same thing. So I don't really care about the order in which I select these 2 people. So what if I had Bob and Charlie? That's not occurred before. Now that's Bob paired with the other 2 possibles. So now I'll move on to Charlie. Let's say Charlie could pair with Alice. But wait a minute, that occurred over there, so that one's not really a new combination. And what if I said Charlie could be paired with Bob? But that one already happened here, so that one's not really a new combination. Now I've exhausted the possibilities, so there are only really 3 different ways that we could select a pair of people, or 2 people, 3 ways to do this. And the last one that I want to know, let's say we need a set of 3 people. What's the scenario this time? I need people to enter into some sort of a game where you need 3 people to play the game. I don't know what sort of game that is, but anyway, let's pretend we need to select 3 volunteers. Well, there's only one way we could do that, because there's only 3 people there, so we'd need to select all 3 of our friends here, Alice, Bob and Charlie. There's only really one way in which we could do that. Now the important numbers here, let's talk about the numbers. There were 3 people in the original set to choose from. Here I was choosing 0 people and I ended up with an answer of 1. Here I was choosing 1 person and I ended up with an answer of 3 ways to do this. Here I was choosing 2 people and I ended up with 3 ways to do this. And here I was choosing all 3 of them and I ended up with 1 way to do this. Now wouldn't it be nice if we had some mathematical function that would give us these answers without going through all this giant list of possibilities? And we do. The way that this happens is called, in mathematics, combinatorics, and the formula is NCR. fancy looking formula. I'll talk more in a moment. And the rule is n factorial over n minus r factorial multiplied by r factorial. Now, what's a factorial? And a good question. Probably should have covered that sooner. Let's see. A factorial n is literally the number n, start with n, then multiply by the number that's one less, and then all the way down until you finish with 2 times 1. For example, if I said 4 factorial, I'd need 4 by 3 by 2 by 1. And that's going to be 24. That's interesting. That's like a little idea that we need to use in our bigger rule here. Now, where do these numbers occur? Well, the big giant number 3 at the top, that is n. That's the number here that goes at the top of our little rule for combinations. These numbers here, the 0, the 1, the 2 and the 3, these are the numbers r. So r is different. R could be 0 or 1 or 2 or 3. And then we would pop it into the formula. And what would come out of the formula? These numbers here, the 1, the 3, and the 1. So let's do a quick example. Let's do some of these. Let's do, now I won't go crazy first. I'll go 3C1. You might think I should have started with 3C0, but I'll do that one in a minute. 3C1. So that's 3 factorial over, now what is n minus r? This is n, this is r, 3 minus 1 factorial multiplied by r is the number at the bottom, 1 factorial. So the 3 times the 2 times the 1, that's the top. Now 3 minus 1 is 2 factorial, and 2 factorial is 2 times 1. And 1 factorial, that's a bit of a messy looking number 1 there. I better make that a bit neater. It's terrible when I can't read my own handwriting. Now a 1 factorial, well, that's just 1. Start at 1, keep multiplying until you get to 1. There it is. Now look what's going to happen. This 2 and this 1 could cancel this 2 and this 1. And I end up with 3 divided by 1, or 3. Now did we find when we did, sorry, lost control of my computer there. Did we find that when we had 3 objects available and we had to choose one of them, there was 3 different ways to do it? Yes, we did. When there were 3 people available, n was 3 and r was 1, there were 3 different ways that this selection could have happened. Let's try 3C2. So that's 3 factorial, that's the number n from the top. Then I have 3 take 2 factorial by 2 factorial. So remember, n is the number at the top, r is the number at the bottom. So again, the numerator is 3 by 2 by 1. Now 3 take 2 is 1 factorial, which is 1, and 2 factorial is 2 by 1. Again, the 2 and the 1 cancel, and I end up with the answer 3. So to say in words what this means, when I have 3 people available, and I need to choose 2 of them, there are 3 ways to do this. Now I should emphasize that in this process, particularly if we look back here, where's my red pen gone? When I look back at this one, the order in which the people were selected didn't matter. So we use combinations when the order does not matter. Okay, I think that's enough for now. I will do another little video talking about 0 factorial soon, because that's a whole different story and it's important to understand that. So that's enough for now. Have a nice day, and I'll see you in the next video.